Okay, we're going to look at, as I said, last topic for the first test. It's about solving formulas for a variable. So you're going to have something like this. You're going to have a formula. What's a formula? Formula is, you've seen them in science all the time, right? It's essentially an equation that involves multiple variables, right? In this formula, this is for the area of a trapezoid, and we're solving for area by plugging in the lengths of the bases of the trapezoid and the height of the trapezoid. If I plug those numbers in, it outputs area, right? Probably remember that from last year. So when we want to solve a formula for a different variable, like what if we want to solve this formula for lowercase b, right, for b? Well, then we're going to get a new formula where we're going to have b equal to some stuff on the other side, and the stuff on the other side is just going to be a mishmash of all the other variables, right? It looks complicated because there's all those variables up there. It's not. It's exactly the same stuff you've been doing. Exactly. The only difference is we've got variables instead of numbers, but you're going to do the same inverse operations to isolate the variable. Only difference is instead of moving numbers around, you're moving the other variables around. No big deal. Let's look at a couple examples and you'll see what I mean. Okay, so we want to solve this for b. Can we point, give me thumbs, can we point to a single lowercase b? We can, right? And remember, in algebra, variables are case sensitive. Uppercase b and lowercase b are different variables. One of them stands for probably the longer base, and one of them stands for the shorter base, maybe something like that. But they're different. So I can point to a single b so I can isolate it. Okay, what do I do? What do I do first? Multiply by 2 on both sides, don't I? Right? I want to get rid of the fractions. So we're going to clear fractions, multiply by 2. I like it. And what happens? If we distribute that 2, we're going to get 2a on the left, and then the 2's are going to cancel in the fraction on the right. So we cleared the fraction. Okay? Give me thumbs. That all make sense? Look pretty familiar? Okay? All right, what's next? This is a little bit tricky. What do you think? What's next here? Okay, you could distribute. It would work. In fact, I think in our textbook they even suggest that, but it's really not the best thing. It'll work, but what else could you do? You can, right? If we're using inverse operations, remember that we work from the bottom up, right? We don't get to parentheses until the last step. So the first part of inverse operations is about doing all this stuff right here outside of parentheses. Right? So what's being done outside of parentheses in that step? We've got this quantity in parentheses that contains our b. What's being done outside of parentheses to that quantity? It's being multiplied, right? And how do we undo multiplication? Divide. So we're going to divide each side by h. Okay, which is going to cancel that h, which is the whole point, right? Now that's starting to look a little better. Now we just end up with, on the right side, we've just got capital B plus B. On the left side, it looks messy, but that's all right. We get what we get. 2a all divided by h. What's the last step? And now finally, we get down to the parentheses after I divide by h, and so the last step would be to undo whatever's being done in the parentheses. What's the last step to get that red b by itself? Subtract capital B. There you go. And we got it. There's our answer. Okay? Scoot that up a little bit. Give me 1 to 5. Does that all make sense? You see that that's the same stuff we've been doing, only difference is with variables instead of numbers? Okay, let's try another one. Same situation, same exact formula, only this time we're solving it. Uh-oh, what happened there? Oh, that's right. Hold it. No, is that right? What were we solving for? We were. Okay, this got messed up. Dang it. What the heck happened here? Okay, I want to solve. Tell you what I want to do here. Let's change this. Did I? Oh, I got that all messed up. Here, I'm going to fix this. Hang on. Give me 1 second. Okay, what about this now? So same formula, only this time we're solving for a different variable. We're solving for h. What do we do first? Multiply by 2. We still want to clear the fractions. That part didn't change, did it? So we're going to multiply by 2, clear the fractions. Okay, that's good. So that gets us there. Now what? No. Divide. Okay, good. How come? Because what's being done to the h? It's being multiplied by that whole quantity because it's next to it. That implies multiplication, right? So last step would then be just to divide by that whole thing, right? Which is going to cancel that factor from the right and gives us our answer. H by itself equals that. And then we'll just flip the equation around. So the h is on the left side instead of the right side. So it looks better. Okay? Give me thumbs. How we doing? All right. Okay, last one here for our, then I'm going to have you do one on the board. How about this guy? We have an equation with a whole bunch of variables. We're supposed to solve for v. So here's our v right here. We want to solve for that v. Take a second, get your bearings, and tell me what I'm going to do. And there's your order of operations tree. We're using inverse operations. So somebody new. Be brave. Okay, so we're working bottom up with inverse operations, right? Okay, so we'd want to see if there's anything we need to add or subtract first. Yeah, look, we have this term right here. Look, these two terms are being added or subtracted, right? Does that make sense? Really what I'm doing is I'm adding to this second term that's got the v in it, I'm just adding that 3pg squared, aren't I? Everybody see that? Okay. So how do I undo addition? I subtract, yeah. So the first step would be we're going to subtract 3pg squared from both sides. And what's that do? Well, it's going to cancel the 3pg squared from the right, isn't it? Okay, on the left, those are not like terms. W and that term are obviously not right terms, or like terms, right? You have different variables in them. So we just get a kind of a big looking mess on the left side, but that's okay. We get W minus 3pg squared equals, what's left on the right side? Negative 7 PV. Okay, good. Negative 7 PV. And last step. What do you think? Somebody different who hasn't contributed yet. Let's get a new contributor. Be brave. There's no bad answers. What do you think? Ideas? What do you think? Yes, sir. I like it. Yeah. Right? What's being done to the V? It's being multiplied by negative 7p, isn't it? Right? Because those are all next to it. So we're just going to undo that by dividing. and that cancels that whole factor, and we're done. That's V. Okay? We just leave it like that. It's fine. It looks messy, but that's all right. It's just our new formula. Okay? All right, you guys go to the boards and try one of those. Solve that formula. Oh, real quick, before you do, remind me about something. Everybody look up here. What am I going to do first here before I even begin isolating? There's something that looks a little goofy about that. Can we rewrite that in a better way? Yeah, okay, good. Big fraction, right? Big fraction. Instead of multiplying by n over 2, let's multiply straight across. So we're going to get V equals n times the quantity B plus L, all divided by 2. Everybody get that? Okay, now go to work. Yeah, go ahead. Yep. Okay, to solve, well, first step, multiply by 2. Good, we're going to clear fractions. Good. So we'll multiply each side. Multiply each side by 2 to cancel the 2's. Okay, listen, there should be no talking right now, right? Thank you. So we got rid of the 2's. So then we've got 2V on the left equals n times the quantity B plus L. Okay, what was your thinking here? Divide by n, because outside we have to undo stuff outside of parentheses first, right? So the quantity, the parentheses that contain the L are being multiplied by n, so we have to undo that by dividing by n. Could we have distributed the n? Yeah, you could. It's fine. But really it's a little bit tougher. It's easier just to always use inverse operations. Okay? I think when you're doing this, sometimes you'll notice when you're doing this on the assignment, the help me solve this and the view an example, I think they're going to tell you to distribute, which I don't agree. You can, right? But I would ignore that. I would do it the way we do it instead. Okay, so now we're almost there. 2V over n on the left equals B plus L on the right. Last step to isolate that L, subtract B. We got it. We're going to... There we go. L equals 2V over n minus B. They're separate terms though, right? The B is being subtracted outside of that fraction, from the fraction. Okay? Give me thumbs. How we doing? All right. Click those Chromebooks all the way closed, please. So last one, just a quick formula example. The last question or question or two on the homework has to do with just plugging values into formulas. Piece of cake. What are formulas for? Well, this is a formula where we've got C, which stands for the temperature in degrees Celsius, is equal to some expression on the left with the variable F, which is temperature in degrees Fahrenheit, right? So the whole point here is we can input temperatures in Fahrenheit, and the formula is going to output or give us the corresponding temperatures in Celsius, right? So what do they want us to calculate here? Day's high temperature in Phoenix, Arizona was recorded as 122 degrees Fahrenheit. They want us to calculate that temperature in degrees Celsius. So what do we do? Say it again. Okay, just plug in 122 for F, right? Okay, so that gives us C equals, now the 5/9, while we're at it, we could even just write that as one big fraction, right? We could write that as 5 times (122 minus 32) all divided by 9, right? We could just end up multiplying by 5/9, but that looks a little bit easier, right? And now I just simplify. This is old school stuff here now, right? We've been doing this for a while. What would we do first to simplify? subtract. Now that's parentheses first when we're simplifying, right? So 122 minus 32 is what? Good. And then we could multiply straight across, but it's easier to reduce if we can. What can I do? Because these are being multiplied, I could just reduce this, couldn't I? Right? If they were being added, I could not. But because they're multiplied, I can. Right? So we could do something like we could trade the 90 over 9 for a 10 over 1. And now when I multiply straight across, I get 50 over 1. So my answer is 50. Okay, I want to point something out though, because the most common mistake people make in math, even in my calculus class, people sometimes still make this mistake. See how this is different from, what if I had 5 plus 90 over 9? Could I reduce the 90 over 9 here? I can't, right? I cannot cancel here because the 5 and the 90 aren't factors. They're not being multiplied. Because those are being added, I can't do any cancellation there. I can only cancel things that are being multiplied. Okay, make sense? All right, I'm going to turn you loose and let you work on this.